So, why do we care about the number of valence electrons? Well, if you have full valence, that means you're stable or non-reactive. Another name for non-reactive is inert. Okay, so all inert elements have a configuration of ns2 and p6. Or in other words, s plus p, which would be 2 plus 6, which gives us 8 valence electrons. 8 is great. Okay, in other words, we have something called the octet rule. All elements that have a full valence energy level have 8 valence electrons. It makes them stable, means that their ns2 plus np6 will add up to 8 valence electrons. Okay. Now, to get an octet, there are two ways, meaning every element on the periodic table wants to get an octet. There are only some that actually have an octet. Most of the elements on the periodic table do not have an octet. They want 8 valence electrons, and there's two ways they can get there. The first way is they can lose enough electrons to get back to the ns2 np6 for the previous energy level. Go back to our example of sodium. Sodium has 11 electrons as a neutral atom. That means that its configuration is 1s2, 2s2, 2p6, 3s1. We already said that this is its valence right here. So it has 1 electron hanging out in the third energy level. What it can do is it can lose that electron. So this electron can go away. Okay, so it can give it away essentially. And then when it does that, its remaining electron configuration is right here. Notice that right here, this is its new valence, and it is ns2 np6, meaning its electrons are in the second energy level, but it has 2 in the s sublevel and 6 in the p sublevel, which gives it a combined total of 8 valence electrons. So it's happy. Okay, but notice in order to do that, it lost 1 electron. Okay, now let's look at it the other way. The other way is it could gain electrons to have enough electrons to have ns2 np6 for its current energy level. So in other words, again, sodium, which has 11 electrons, right? Its configuration again is 1s2, 2s2, 2p6, 3s1. Okay, so in order to get to the ns2 np6 for the current energy level, we would have to fill this s, so we'd have to go from 3s1 to 3s2, right? And then we'd also have to fill the p sublevels, so it'd have to be 3p6. Okay, so to get from there to here, we had to add 1 to fill the s and 6 to fill the p sublevel, so we'd have to add 7 electrons. Okay, so here we lost an electron, here we gained 7, both of which got sodium to an octet, 8 valence electrons. So which way should it use? Well, it turns out that elements want to use the shortest route possible. So for sodium, it would rather lose that 1 than have to gain 7. It's too much work to gain 7 if you can just lose 1. Another example, very similar, notice sodium was here, potassium is just below it. Just like sodium, it would rather lose 1 than gain 7. Gaining 7 is a lot of work when you can just lose 1. If it loses 1, it ends up looking like argon, okay, meaning it has 2 electrons in the 3s and 6 electrons in the 3p. Nice octet. Fluorine, on the other hand, which is over here, okay, fluorine would rather gain 1 to look like neon than to have to lose 1, 2, 3, 4, 5, 6, 7 to look like helium. Okay, so it's easier, it's a shorter route to just gain 1 electron. Rule of thumb is, generally speaking, you never lose or gain more than 3. Okay, and this is a general thing, meaning there are some exceptions, but generally you never lose or gain more than 3, and that means electrons. So you can gain 3 or you can lose 3, but you're generally not going to see 4 or 5. Okay, there are exceptions, but for right now, if you ever have an answer that says you're losing or gaining more than 3, then you're probably wrong. Okay, Now be careful, because if we look at these two guys here, boron and aluminum, meaning group 13 or 3A. Okay, I use aluminum as an example here, but this includes boron. These elements, they want to lose 3. Notice you just shoot across here, that's 1, 2, 3 to look like helium. Or with aluminum, it loses 1, 2, 3 to look like neon. Okay, if we go the other way to the right, you'd have to gain 1, 2, 3, 4, 5. Again, you're never going to lose or gain more than 3. Okay, so be careful with aluminum and boron. Just because there's this big gap here, that doesn't mean they have to lose lots of electrons. They simply lose 1 to go back across, then another one, and then a third one to get to their valence. Okay, so there's an idea here that we haven't talked about in a bit, but we need to review it because now it's going to become really important. And that's the idea of an ion. An ion is an atom that has gained or lost electrons and now carries a charge, positive or negative. So remember, up until now we've always said that atoms were neutral. So when we looked at the number of protons, we said that was equal to the number of electrons. In other words, the number of positives was always equal to the number of negatives to cancel each other out. Now, however, the number of electrons are going to change. So that means that we're going to get a charge. So how do we determine that charge? Simple way of explaining it is every time you gain an electron, remember electrons have negative charges, that means that your charge of the atom is going to decrease because you're gaining a negative. Okay, so for every electron you gain, your charge decreases by 1 or goes down by a -1. So if you gain 3, your charge is now -3. If you lose an electron, okay, meaning you lose a negative charge, that means that essentially now your charge has increased by 1 or becomes +1. So in the case of sodium, right, we said that the easiest thing for sodium to do would be to would be to lose 1 electron. And if you lose 1 electron, that means that sodium becomes Na+1. With fluorine, the other example we talked about, fluorine wants to gain 1 electron, so its charge, it's gaining 1, so its charge will decrease by -1, decrease by 1. So its symbol would be fluorine -1. Okay, both are ions. They're both now more stable because they have their octet, but they carry a charge. So sodium carries a +1 and fluorine carries a -1. Right? Make sure that you answer your WISC questions. Make sure that you come up with your hot question. You write it down on your Unit 5 cover page, and we'll see you tomorrow.